Okay, so let me just pick out a reasonable problem, and then we'll go from there. Have you done many leak codes before, or is this sort of thing where
I
you?
only do neat code, so I've done around 33. So
Okay, so
my
you've
approach
done
is not
some.
really to like memorize the patterns. I kind of just
Okay,
rely on intuition
okay.
and go
Well,
from
that's
there.
good. That's the way. I mean, that's kind of the way you should be doing things.
Hmm.
So that's good. Okay, cool. In that case, I don't think this problem is in leak code. Let me. Well, I've done neat code a long, long time ago now, so I don't remember all the problems there. But yeah, we could definitely get you started here. Okay, so are you in? You're in. Great. Yeah, please change. Please feel free to change the language to what you prefer, and we'll kind of get in there whenever you're ready.
Yep. It's already set to Python 3, so I
Okay,
think I'm ready to go.
is that your preferred?
Yep.
Okay, great. So then let's just get started. First of all, welcome to the mock interview. Glad to have you here. I believe it's the first time we've spoken about this, but let's just get right to it. So the format here is going to be an hour, like a real interview, and realistically speaking, you'll have about 45 to 50 minutes to do the problem. So that's sort of our target here. Okay, and I'm gonna
Yep.
have you control the time on that one. Okay, so it's for up to you to look at the time. Um,
Okay, sounds good.
yeah, and then so we won't do introductions here. We'll just get right into it. In real interview, of course, you'll be talking a little bit. At the end, we'll save the 10 to 15 minutes for feedback and any questions you might have. Okay.
All right,
All
sounds
right,
good.
so let's just get right to it. So the first problem I would like you to write is a function called closest points. Okay, and the function is going to take in a list of points and an integer in. Actually, let's call it m. Okay, and these points are two-dimensional Cartesian points on the xy plane, and you are to
Hmm.
return me the m closest points to the origin in this original list.
Okay, gotcha. A list of two-dimensional Cartesian points. X, Y, I'll just call the coordinates X, Y, integer M. Could you remind me again what integer M represents?
That is the number of points that I want returned.
Okay. We want, okay. And then we just want the M closest points to the origin. Okay, sounds
That's
good.
right. That's right.
Okay. I'm just gonna take a second to think here. M closest points. So I think for sure we have to check all the points. So at minimum, this is going to be an O of N operation. So I'm just trying to think right now, what is the criteria that we should check to see which one is closer? So I'm thinking Euclidean distance. So that would just be squared plus y squared, something like this. Okay, so then I guess like I'm just gonna work through like a naive solution first in my head. So we would go through each point and then kind of check Euclidean distance, and then we see whichever one is closest. We take the m top m smallest values, and we would just return that. So I think the actual difficult part of this problem here is that we need an efficient way to actually obtain the top m smallest, I guess, distance to the origin. So I'm just trying to consider what's the best way to do that. Um, Obviously, the easy, like naive solution would just be to sort it so that we would pay in log n after we've taken all of the kind of the Euclidean distance, and then we just sort it, and then we just go through and take the top m. So that would be in log n. I'm just thinking maybe if there's like a better way to do this. Let's think. So maybe I should work. I'm gonna write down a small example first.
Hmm.
Okay. Mm, okay, and then origin should always be 0 to 0. Okay. Um, are negatives okay? I guess negatives don't really matter, right? Because it's Euclidean distance. I feel like I might be missing something. I just need to make sure I don't get anything wrong with the problem setup. So Cartesian points, m number of integers. Are there any weird edge cases here? I can't think of any off the top of my head right now, so I'm just gonna
Okay.
keep going, and then maybe we might encounter one down the road. And one again. So let me just think. If we always take the Euclidean distance to 0, and then this one would be, okay, so this would just be 1 squared plus 2 squared. So I'm just going to write down the actual Euclidean distance for each point. This one would be 1, 4.
If I may recommend, you just pick easier points to make Euclidean distance.
Yeah, I don't think I actually have to take the square. Kind of just look at the value inside.
Okay.
Um, but yeah, I suppose these points are going to be, right, they're going to be in the same order anyways. Okay, let me think. Um, okay, no, I think I'm focusing on the wrong thing right now. Like the difficult point that I need to work through is not if how the Euclidean distance works. Like that's pretty obvious. What I need to think about right now is if there's an easier way to obtain the top m numbers. So maybe there's a way, I'm thinking maybe like a heap or something that I can like sort the values as I calculate the Euclidean distance. So like I can keep adding to the data structure and the data structure will keep ordering itself to maintain like the top m kind of smallest units. This reminds me kind of the there's a Leetcode problem I recall called K top K numbers or something like that, where you
Okay.
maintain the M or like K smallest numbers in the string. So I'm thinking if this would apply in this situation right now. From what I can recall, that was in that problem you use a heap, and then you would heapify it each step. You would push to the heap. And then the way is, I think the trick to that problem is you would make sure the heap is of size m, which is like the top amount that we want to keep track of. So this would still be in log in the worst case, but if our integer m is significantly smaller than n, I believe this would be an optimization over just sorting every single point after finding the Euclidean distance for each. So, okay. Does it kind of sound like I'm on the right approach, or do you think we could simplify this even more?
I mean, that sounds like it's. I mean, that sounds plausible. But do you think it's more efficient just in your head, or do you have some math to back that up?
Okay, so I guess I should kind of step through an example. So let's say we have n points, right? And then let's say m is like quite small. Like n could be like 10,000 or something, but let's say m is just like uh I don't know, just 15, right? So I need to essentially convince myself that this is actually a significant optimization here. So when we maintain a heap, so when we insert, we need to heapify up, I believe. Right, I believe it's to heapify up. So we would maintain a min heap in this case. And from what I recall, whenever we heapify, it costs log n because we need to traverse from bottom to the top of the, I guess, the heap tree. So then, at most, if our tree only has a constant number of elements, so O of 1 elements, the heap is at, at most size O m. Usually it would be log n, but then I guess in this case it would be log m, I believe. So then at most m would be the same size as n, so we would run log m in times. Okay, so I guess the runtime is not even in log n at the worst case. It would actually be in log. Oh no, sorry. It would still be approximately in log n. But I believe that this would be a significant optimization, yes, over just sorting the inputs. Because we're
Okay.
essentially what we're
Yeah.
doing, like when we sort, like we're considering all of the elements together, but then using the heap data structure, because we're making sure its size is of only approximately m,
Okay.
we're only considering the minimum, like the exact subset of elements that we need to keep track of. And then in the end, we want the top m elements, we would just pop everything off the heap. So then that would also cost uh, essentially m log m, which is approximately in log n if m is very close to n. Okay, I'm just gonna think, did I miss anything else?
Sorry, can you just clarify to me
Um,
really quickly again what the m log m is from?
Right. M is the number of points that we want, right? So M,
Yes.
we want the top M smallest points, or like
Yes.
points with the smallest Euclidean distance, which means they are the top M points closest to the origin.
Yes.
So our heap will keep track of just this for us.
Okay. Yeah. Go
So
ahead.
I think this approach seems fine for now. I'm just going to, I guess, start coding this up because I feel like I'm clear with how it works. And also, I'm pretty convinced that the runtime is an optimization over just sorting the inputs. So I guess I'll just start coding for now. And then if I encounter any issues, I can maybe revise my plan. So I'm just going to look up some of the Python heap stuff. Yeah, it's been a while since I've used this. Let's see,
Hmm.
heap queue. All right, so Python has a heap queue. Do you need me to share my screen so you can see what I'm looking at?
No, I don't care.
Okay, gotcha. Min heap. Let's see, min heap. Okay. Um, heap queue. Okay. Where is the?
What are you looking for?
I'm looking for how to use a min heap, like the data structure. So I think Python should have one built in.
Yes, Python
Um,
has the heap queue library, which operates on an array structure, on a
okay,
list
gotcha.
structure. Yes.
Yeah. I'm just trying to remember, is it max heap or min heap by default? There should be an initialization setting to kind of change what you want.
So the Python heap by default is a min heap.
Okay, great. So that works for me. So yeah, it looks like it's a library, so it takes like a heap input. So you have to keep calling heapify on it. So okay, so I guess we just start with a blank list. So for now, I guess I'm just going to define a new function.
Yeah, you can get rid of these two.
So, and then points. Just gonna write down the stub here. Okay, let's think. So we need an empty list first to. Oh no, no, okay, that's already our function definition. So I could just I'll use this, and I'm gonna make a helper function to get the distance to the origin. To origin. X int. I believe it would just be something like this. X. I think it right in Python it should be this. Right. Okay. Square root. Okay. Let me just look up Python. It should just be math.square root. I have to import that. Float cannot be. Oh, okay. Yeah. I guess I might have to use a float here. Right. I guess I forgot to ask earlier. So are these points? I guess it doesn't really matter. The only thing that matters is do we want an int output or does it not matter? Like, can we return? Oh, right. No, no, no. That doesn't matter. We just want a list of the points. So if I assuming if the original points are all floats, then we should just return the m closest points in floats as well. The original ints, we should return them in ints. So that shouldn't matter here. So just for the calculation, it's fine that if everything is like a float or because we need it for the I guess the square root. Okay. Heapify. Okay. Yeah. So we have this. We have the heap. Okay. So let me see. Is there anything wrong with this? So just this is the Euclidean distance function. Okay. This looks fine. Okay. Right. Okay. So I'm just gonna have to think. I need to step there. So we're given the list of points, so we need to do minimum one pass through. So then at each iteration, we are going to push a point. Okay, no, I should write this down. Iteration, iterate through all points. Okay, so we have to push it into the heap no matter what, I think. Push. Wait, do we want to push this into the heap? Okay, so we push into the heap and we heapify. Does the heap actually maintain the top m closest or smallest elements? Because I know heap only loosely sorts the elements, but does it actually maintain the top m smallest here? Let me think about this. So if we had push, okay, so I'm going to just work with single digit numbers for now, just to so I have an easy example. So let's say we do okay, sure. We have some okay. So for now I'm just gonna treat these numbers as in the smallest number comes first. So the -1 would be the smallest, and then 1, and then 2. So I gotta think if I push this onto the heap, first iteration, our heap has 1. Second iteration, we have 1, 5. So these are still the smallest numbers we've encountered so far. Let's say that m is 3. 1, 5, 4. And then we keep going. So here is when we have to start popping something out of the heap. Oh, okay. Right. Okay. So I think we might have to use a max heap. I just realized because the heap, we need to get rid of the largest numbers. We want to maintain the top m smallest number. So, because when you pop off from a heap, the top number that gets removed is actually the smallest with the min heap, which is what we don't want. We want to keep the smallest elements. We want to get rid of the largest. So it would make sense that we actually want to use a max heap here. So I just need to update this. Okay, so we just need to remind ourselves to use a max heap later. Okay, so then we get to this step. If it was a heapify, okay, so then this would be this 5, 1, 4, just rough ordering 5. So here, when we call this, we check the size of our heap, and we know that it's over the limit. So what we're going to do is we need to pop off the max because it's a max heap. We get rid of that. And then is this okay? Does this give us the top end? It will always remove the maximum number. Okay. I think I'm just going to try to finish this example to try and convince myself and see if it does actually give me the top m smallest numbers. 1, 14. Okay, right. So we're right here. I'm not going to worry too much about the ordering the list. I'm just thinking of when we're popping off elements. So 1, 4, 2. Next, we push 12, and now we've exceeded capacity. We need to pop out a number. We need to pop. It's going to, when it heapifies, it's going to move 12 to the top. And then we're going to get rid of 12. So 12 is gone. And the next iteration, we add 15. We heapify again. 15 gets moved to the top. 15 gets popped off. So 15 is gone again. So, okay, it looks fine so far. And then here we go -1. -1 is the smallest. So the top of our heap right now would be 4 after we call heapify, after pushing -1. And a 4 gets popped off. And then we're left with 1, 2, and -1. Okay, so I feel like this is fine. So if n was 3, 1, 2, -1. Yes, these are indeed the m smallest elements. So I think this approach is fine. I just need to remember to use the max heap. Okay. Yeah, so I think I'm ready to start coding more. So heap. Let's think. So heap needs to look at the Euclidean distance. That's what we use the comparison function for. So okay, because I need to keep track of both the points and the Euclidean distance to the origin. So I would think about using like maybe like a pair tuple. But I need to make sure that the heap actually heapifies or like sorts the elements by that um, by the Euclidean distance properties. So I'm gonna look up the how heap, because I believe in Python some sorting functions like dictionaries, they'll just look at the first element of the tuple if the input elements are tuples. And it should, if I put the Euclidean distance in the first part, it should evaluate and sort by the comp. So sorts objects the same way in list.sort does, so just define a comp method within your class definition. Okay, heap. According to this, you can use tuple, and it will sort by the first element of the tuple. So if you don't want, you manually extract. Okay, so it seems like the heap will just work on tuples. So contains list of. So I guess the data structure here will look something like this. And then if the heap works as expected here, it should just sort by the Euclidean distance, would just be a float here. So I think that's fine for now. Okay, I'm gonna start writing out the for loop. Okay, so let's think. So we need to add distance. Yeah. Add the distance. Right. So we need to do. I think it was something like heap q dot heap push points. Okay. So we push. Oh right. Hang on. I need to make sure I'm initializing it as a max heap. So I'm just gonna look up how I do this real quick. Python. Initialize max heap. Heapify max. Okay, so the function, so it just seems like whenever we use heapify, we just call the heapify max function. Okay, so that seems fine. But then heap insert, does that just, because when you heap push, um, I think this might do the heapify for you. So I think what I'm supposed to do here is actually just push it into the array, like just straight up push it in, and then I call heapq dot heapify max like this. So I think it would be something like, okay, so we need to end, or oh, right, okay, so per point equals points I, okay, and then we're going to do this. That would be the x coordinate and the y coordinate. So append this. I believe when you create a tuple, it's just like this. So that's the result of that, and then points. Okay, and then that's right. This should be parent points. So this would just be a tuple of this. I'm just going to double check this is how you make a tuple. Python tuple. Right, yeah, it's just inside curly brackets. Okay. Or I mean like brackets. Append, okay. And then we call heapify max. And then here we need to check off largest element. And then here we do, I believe we can just do length. equals m. It's m, and then keep q dot pop. And I know it's I saw the function earlier. Yeah, let me just double check again. Where are the max heap? Heap pop max. Okay, so it's heap pop. Oh, okay, so it's not autofilling right now. Wait, so heapify max is this? Heap. Let's see, heapify max does when I do the pop. Okay, so there's no heapify pop function. I feel like I might be missing something with how I'm supposed to be using the heap. Let me just look for like a more in-depth use case somewhere so I can just copy it. Python max heap example. Should be at least one, right? Let's see. I keep finding implementations except instead of the actual like library. Okay, so heap max push index to update. Max heap. Maybe if I just look at the actual function definition, it'll be faster. Oh, I guess there's no documentation here. Okay, let me just look at the official documentation.
Yeah, so Python does not have a max heap. All heaps in Python are min heaps.
Oh, okay. Okay. If they're all min heaps, then I could probably just use a hacky fix where I just return the negative square root like this. So then the like the largest number would become the smallest number. So I think that also works, but it is kind of hacky, but I think it's good enough for the purpose of this interview. So heap q dot. Okay, so I'll just do this for now. So return negative math dot square root. Okay. Heap dot heapify. And then I can just do heap pop. I could just do heap push here. Then. I think I have to do this. So it can just be heap q dot heap push distances, and then oh, I shouldn't have gotten rid of that tuple. Let me grab this. List and then item. Okay, that looks fine. 0, 1. F length m pop distance. So this should get rid of the largest element. Okay. Okay, that looks fine. And then we would just return, right? We only want the points in the end. So we need a way to actually, I guess, get rid of the points. Let me think right now. Because then we'd have to iterate through the entire heap and just grab the points, which is fine if m is small, but if m is roughly the same size as n, because I'm assuming the actual distance or like the values of m and n would be something like this. Is this correct?
Yeah, that's right.
So like, okay, yeah. So I kind of want to avoid iterating through it again just to grab the tuple. So then that would mean that we would have to actually, I think we would have to initialize some second data structure alongside and then kind of manage like a list, like a return array with just the elements of the, like just the points, because we don't want a tuple, we just want a list of points. I gotta think about how I'm gonna do this right now. Well, actually, no, I should probably just run this and make sure my actual algorithm works first before I worry about making further optimizations. So I'm just going to run this first and see how this works. I think I'm going to need a main function. Let me just grab one real quick. Okay, so it's just literally just this. Okay. I'm just gonna, I don't know, insert some random data points. Okay, and then just at the top 4 points, so we're gonna call this. It's just gonna be the input is simple. Then points. Okay, and then let's print this out and see what this looks like first before we get ahead of ourselves. Grab that. In red format. Oh, what's going on here? Finished in 1 point. Okay, so it's not really printing anything right now. Did I miss something right now? This main. Oh, no, that's not the actual main. I just realized it needs to be right. It's like this, and then you run main from here. So I believe it's this. Okay. Okay, so it's still not printing. Oh, okay, there we go. Okay, now we got a 1, 2, 3. Oh, okay. Okay, so wait. So we got 1 point, 2 points, 3 points. Okay, so our M is 4. That's kind of weird. Let me think about this. Why are we returning 1 point less? Okay, this should be M plus 1. Right, because the array should be size M, because then if we keep popping, as soon as it reaches size M, it's going to be always 1 less. Okay, so let's see. Are these the smallest? 5, 4, 0, -2, right? The heap doesn't necessarily return it in order, but so 3. I should actually double check this to make sure that these points are actually the closest.
Yeah, no, that's
So
fine.
I would expect to see 0, 0. I would expect to see 1, 2, 4, 0, and then maybe okay, wait, hang on. So for sure we expect 0, 0. This is for sure. 1, 2, yeah. Maybe I should just change one of these to 2, 1, so it's pretty obvious which points are going to be the result. So 0, 0, 1, 2, 2, 1. Okay, and then I'm just gonna change M to 3, so the output is a bit easier to read. So 1, 2, 2, 1, 0, 0. Okay, so the behavior looks as expected right now. We are getting the smallest values. Maybe let me try a negative value. So, okay, yeah, so the Euclidean I need to test that the negative values are working properly for my Euclidean distance. So, like, let's do -3, -1. So this, wait, hang on. So what am I trying to test here? I'm trying to make sure that negative values are not being treated as the smallest. So like -15, like Euclidean distance on the, like you shouldn't have a negative Euclidean distance. Right, I just need to make sure that it doesn't treat -15 as a value smaller than 1. It should just be, like whatever is closest to, like smallest in the absolute sense. Right, wait. Okay, okay. I don't even know why I'm worrying about this. The Euclidean distance function should be fine. Yeah, okay. So this looks fine for now. So I think I'm going to go back here and see if there's a better way to, I guess, optimize the actual returning here. Because I don't want to just iterate through and like remove the point from the tuple and then like push it to a list. So that could be potentially pretty expensive. So what I need to do is I would have to maintain like I think maybe I guess a set wouldn't work. So what would work here? Um I'm thinking maybe if there's a way I can directly pass a comparison function to the heap. So then it would just do the Euclidean distance thing for me, and I don't even have to store the Euclidean distance. I think that would be the most elegant solution here. Um, so I'm just going to look into see if I can do that. Fine. TQ sorts objects the same way list.sort does. Just define a comp within your cluster. Then we need a class. So then, okay. Let me see if there's like an easier way to do this. In heap. Okay, wait, before I okay, yeah, no, it's fine. Okay. Um Python custom X PQ comparison function.
What's the goal here?
The goal here is to essentially avoid because our requirements for the function is we want to return a list of the m smallest points, right? But right now we're returning the m smallest like tuples. Like the point is inside a tuple. So to actually extract the point from the like the list of tuples, you have to iterate through each one and like take the point out, which can be potentially kind of expensive. So I'm trying to see if we can get rid of this step. Like it doesn't change the asymptotic runtime of the function. It would still be big of m log m, I believe, but I just want to see if there's like maybe a way to avoid this as well. Does that make
For
sense?
now, don't try to avoid it.
Okay, yeah, sure. Let's just not worry about that for now then. So let's go through the I'll just do like the brute kind of the dumber solution. Or I mean like just grab the tuples, the points from the tuples, right? So so should be iterating through this. Uh just do this. And it would be something like parent array dot and distances I and then the splitting distance the first one, so it should be this. So let's just run this and see how it looks. Negative one, negative. Okay, this looks as expected. So in the case where you have like point like 1, 2, and 2, 1, they have like the same Euclidean distance from the origin. Doesn't matter which one we return.
Say again.
In the case where 2 points are like tied, does it matter which one we return? Can we just return either one?
You want to return the one that appears earlier in the list.
Earlier in the list. Okay. Let's see. So we return 1, 2. Okay, so 1, 2 comes earlier in the list, but we actually return 2, 1. Um, okay, so this is kind of a weird edge case. It's actually kind of difficult to deal with. I just have to write this down. If 2 points I turn the one closer to the return the one that comes first. Okay. Right, this
Actually,
is actually
for now, let's forget about this. So you can return anything.
okay. So we can just return anything. Then I think my solution right now is fine. Do you have like you want me to like just use ChatGPT and like generate more complicated input to
No,
test
no, that's
or
fine. I think it's correct as well.
okay.
Can we go over the time and space, please?
Okay, yeah. Um sure. So get distance to origin. unless we're working with some like freakishly large numbers, this shouldn't be much of an issue. So this is just constant time here. Constant time. Okay, initialization here. This is constant time. Yeah, so for the for loop, we're paying O of n. We'll loop through the entire list here. So push the point. Wait, hang on. So I'm gonna write this down. In iteration. So for each iteration, grabbing the point is constant time. We'll push it onto the heap. So this is potentially operation heap pop. Heap pop, because when you pop an element off the top of the heap, you have to heapify down. So that's also, oh, that's the same operation cost as well. So that should also be log of m. So then this would be n log m, okay? And then at the end, we just, all right, hang on. I'm going to write down the total runtime for this loop here. So this would be O of n log m, okay? And then here, let's see. So I in range of length distance. Okay, so we're just iterating m iterations. And then we just do constant time operation for each. So that's just, total cost is just, in the end, we have plus O of m. And I think asymptotically, it should just be, this is the total runtime of the function. So it should just be n log m. So the optimization we achieved here without just sorting the entire list with like the dumb solution is that it becomes log m instead of log n, which is like a potentially a very big speed up if m is significantly smaller than n. And as for the space complexity, let's see. So we initialize a heap, and so okay, so the heap is always of max size O of m. So I guess let's just write the space complexity here. It's just going to be let's see. So the heap is always of O of m, right? So the heap is. Do we use any other stuff? Okay, so I guess we technically use this list as well. Asymptotically, it's the same. I don't know how the Python compiler exactly handles the freeing of old arrays. Oh, okay, no, so I guess it wouldn't be freed here. So our total cost would be 2 of 2m as O of 2m, but then that would still be O of m asymptotically. So our space complexity is still O of m, I believe. Yeah, I think this looks fine unless there was anything else I missed.
Okay. Yeah, sounds good to me. I think we have time for maybe one or two quick follow ups. So let's just run through those as well.
Yep.
So the first follow up I would say is, if I can guarantee that m is proportional, the size of m is proportional to the size of the points, would your approach change?
All right, could you repeat that again? Like, what do you mean by m is proportional to the size of the points?
Yeah, so m is dependent on the size of the point. So let's say m is half the size of the list, and it's a proportion,
Okay.
which I don't tell you ahead of time, but I can tell you it's proportional.
Okay, so it would be essentially equivalent to n divided by something,
Yeah,
but it's like proportional to n. So
yeah.
then that would just make it asymptotically n log n, no matter what. But so you're asking if my approach would change with this, like, I guess, okay. Like, would it actually change my implementation, you mean?
Yeah, like if that was the restriction that was given, would you still have written the same algorithm?
I guess it depends on how much we value space because we do use a little bit more memory here to make this runtime optimization. If it turns out that the runtime is going to be asymptotically proportional to n anyways, and we, for some reason, we really cared about saving memory, we could just sort it because then that would just be n log n anyways.
Mm-hmm.
It's asymptotically the same. And then if we sorted instead, we would just use the memory in place. And then we wouldn't even have to initialize the heap, so we could save some memory in that case.
Okay.
So this is kind of like a trade-off between if we value runtime more or if we value memory more in this case, I think.
Okay. Makes sense. And then let me think. Okay, and then I guess another one is, let's say instead of two-dimensional points, we had k-dimensional points. If you had k-dimensional points, what would change? The complexity wise.
Okay, so k-dimensional points is going to, assuming like, if it's like some, I don't know, like machine learning data, k could be like very large. It could be like 1,000 or something. That's going to definitely change our Euclidean distance runtime. So let me just think about this for a second. So I believe, I just need to remember how because then it would be no longer, is it still Euclidean distance? What's the distance function in 3 dimensions? It's not, is it cube root? Let me just double check that. Um, Euclidean distance in dimension. Okay. Uh, okay, so I just searched this up and it says that Euclidean distance might not be a good metric in high dimensions.
It's still square
So,
root. It's still square root. It's the square root of the sum of squares of all the
okay,
intermediate
yeah.
dimensions.
Um, I think in this case, I am aware that there are other distance measures that we can use, so there might be a better one. I'm just going to do a quick search and see if I can find something better than Euclidean distance.
No, we can assume it's Euclidean. That's fine.
Okay. So if you just want to know the change in the runtime rate, okay. So it would just be k dimensions. So then this would cost O of k, which is our number of dimensions. So then here, we would have to pay. Okay, let's see. We call this once per loop iteration. So so then that would just add. Let's see. We just pay this once. So then this, instead of n log m, this would become n k log m, I believe. And yeah, that looks about right. Our space complexity would also obviously go up. We're definitely using a lot more memory now. So then this would be km or mk. Yeah, this is assuming we
Okay.
still use Euclidean distance.
Okay. Yeah, sounds good. Let's end the mock here and let's go into the post game interview.
Okay, sounds good.
All right. So, I mean, usually I open these up by asking you, how do you feel? What went well? What didn't go so well? In your opinion? And let's start from there.
Okay. I think I got a little bit nervous because you were silent for a while. I felt like I might have done something wrong, and I also felt like my train of thought sometimes when I was just talking was a bit incoherent. Like especially when I started talking about how I was going to optimize this part where we like get the return array, I think you were kind of lost on like what I was trying to accomplish there. So I definitely could have been a bit more clear on that.
Mm-hmm.
And I also just feel like I could um maybe a bit nitpicky. I could just brush up a bit more on Python syntax so I wouldn't have to waste so much time on looking up like, oh, like what, how do I get like a max heap or min heap? So you have to just like sit up, come out and tell me like every heap is a min heap in Python. So
Mm-hmm.
I used quite a bit of time on that, which I think I could definitely could
Yeah.
avoid.
Yeah. 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 Um,
But overall, I think I'm like pretty happy with my solution. I think
yeah.
I walked through like my thought process. I guess like another kind of annoying part is I didn't really have a good example prepared ahead of time.
Right. Yeah.
Um, but like I guess in like an interview, usually when they copy and paste the question to the IDE, like they would have an example scenario prepared for you that you can just look at, right?
Yeah. Usually, if they do copy and paste it, they will, but not
Hmm.
always. They'll copy and paste it depending on what they're trying to test. So just be aware of that.
Okay, right.
Um,
Yeah, I think that's
okay. Yeah.
pretty much it.
I think you had a pretty fair and generous assessment there. So I think I'll just add on to that by saying a couple notes ahead on my side, and I'll send you these notes after, so you don't have to write anything down here.
Yep.
Um, yeah. So first thing is first is I think you have a pretty good system for organizing thoughts. That's the first thing I'd say is a strong point. That could be your method taking notes, method writing down examples, etc. Testing things. That thing is. I think that category I would say is a strong suit. So keep that up and keep developing that system for yourself.
Hmm.
That's something which is usually hard to kind of cram. So good. It's good that you have that kind of built up.
Thank you.
Um, Now, a couple of things off the bat, I think I wanted to say, not about just generally, just like not specific to this problem, but just in general. And again, please feel free to like pause and question if anything happens.
Hmm.
The first thing is about the edge cases, right? And as you have noticed, there was an edge case you did miss, which is what if there's a tie? Okay.
Right.
Now, the thing about this is that this is not the only problem where you can have a tie. Okay. Many problems can have ties, right? And
Hmm.
so this is maybe a potential augmentation to your system, which is if you ever get a problem which has the ability to have ties, you should be thinking about in your head, hey, how do I resolve ties? For a lot of problems, it's trivial. There's a very obvious answer to how you do a tie. So for some
Hmm.
problems, it's less trivial, like this one, for example, where you might not know how to resolve a tie. So
Right.
there's a lot of these things that happen, like these edge cases that you need to think of, and I think it could be good to embed these edge cases into your system, right? To kind of make sure you don't miss that in the future. Because in this
Right.
case, by the time you real and by the way, I was surprised you actually caught that at the end. Because usually, if you don't catch it at the beginning, you just never catch it. But by the time you
Hmm.
catch it at the end, it's too hard to
Yeah,
fix
it's
it.
it's
You
already
can't.
too late.
Yeah, like this by the way, and the solution you came up with, by the way, is a good solution. It's a good solution if you don't have to resolve ties, right? So,
Hmm.
so by the end there, I just wanted to see. Okay, you thought you caught the edge case. You saw there was something going on. You were coming up with an idea. It wouldn't have worked, by the way, but you were coming up with an idea, and I just had to stop you right there because it just would be a waste of your time, right?
Okay.
So again, you don't want to put yourself in a situation where you have to scramble at the end. That's not going to help you. And all by the way, if you scramble at the end, most of the time you won't even get it either, right? So
Right.
just be aware of that. That could be a very costly mistake. Okay.
Hmm.
Um, Another thing there, and I want to just kind of just mention this, and you did mention it earlier, but I think this is really important. If you're going to interview, like Leetcode interview, whatever interview, and you're picking Python as a language, the interviewer is going to have a baseline expectation for what you know and what you don't know. Okay.
Right.
Now, it's okay, for example, to not really know the heap syntax. You can search it up. That's okay. But I feel like there were some other things there that was a bit maybe more on the edge. Like for example, you know like I mean the first thing I would say there's a tuple initialization that was a bit surprising. I would expect people to know how to do that one without having to search. There was a comment you made about how tuples are compared. That I would say is also quite important to know. Um, so
I did believe though, like I said the right answer.
you did say
Like
the
it
right
always,
answer.
I just wanted to double check just in case.
Right. I mean, and here's the thing, right? So, yeah, it's not wrong to double check, but again, you have to be cognizant of the fact that you are picking Python to do this task, right?
Hmm.
And this is not like comparing tuples is not an arcane concept in programming,
Right.
and so that's just all I'm saying is that that's gonna peg the interviewer's level of confidence in you at a certain level, right?
Hmm.
Like it's just a perception you're given to the interviewer. Right now,
Okay.
now I will
Gotcha.
also add that yes, it's better to double check and be right than to not double check and be wrong. Right? I'm not saying otherwise. I'm just saying if you had to double check that, the interviewer just going to put okay, well you will know at most you're at this level, right? And so that's just the impression you're going to give off.
Okay.
And that by
Gotcha.
the way, and that you might like that's not like that information isn't unique to this problem, right? That's not a heap question. That's just a tuple. Like that's just a Python question, right?
Hmm.
And so like again, like just be aware of that, right? And the heap details here, I would say, like it's important to know a bit about the heaps. Like you seem to know a little bit about the pops and the pushes. There was a couple things that were a bit concerning. The first thing was that Python is a language that doesn't have one of the two heap types, and so if you want to have the max heap, you need to invert the weights, which you did do, right? But you need to catch that ahead of time.
Yeah.
Right. Now, for example, I would say a reasonable question would be, oh, I forgot what the default heap type in Python was. Can I search that up? That would be totally fine because no one needs to memorize that. But, if it's given to you that, hey, um, it's just a min heap. It's what it is. I don't want you to be spending 3, 4, 5 minutes searching up how to do the max heap variance, right? And
Yeah. Right.
again, this is a bit of a note there as well, which is when you were using the underscore heap push underscore max The underscore in Python means it's a private method, and so it's actually not available. So those are the kind of
Oh,
things that
right.
the interviewer would be like, oh, okay, this person probably isn't very familiar with Python, right? So just be aware of that. If it's a Python role, that'll be not good. If it's not a Python role, that might be less not good, right?
Okay. Right.
Okay, so a couple things at the beginning as well. So you had pretty good. So I think this is a common thread throughout the interview process here, which is that you had good time analysis. That the time complexity was always correct. It was always good. The space is a bit weaker. We'll get to that, but the time complexity was always good, and so that's something which you should continue to continue to practice and acknowledge trade-offs in, right? One thing about the space I wanted to talk about here was, and this is not a problem, but you automatically decided to trade like space for time to get better time, worse space, right? And that's typically okay. That's typically a good assumption to make. However, it's oftentimes good just to check with the interviewer. Hey, I've got these two ideas. I think this is the case for that. I think this is the time and space for option A. I think this is time and space for option B. Do you think I should proceed with option B? I think it's got better time. I want to go with that.
So
That's
you
something.
think I should have presented like the two approaches first to the interviewer and asked them which one they preferred for this
Yes,
problem?
in this case, because you clearly knew the time and space of both,
Okay.
right? And so
Right.
if you have a good confidence, you have a good grasp on that trade-off, it's a strong signal to just say it right off the bat, because then the interviewer can say, oh well, this person already very quickly grasped what the trade-offs are, and so it's
Hmm.
good to kind of bring that. Now, if you don't know, if you can only think of one option, or if you don't know the time and space of the other one, you can keep a higher level. Say, hey, I have these two approaches. I don't know which one to take. I'm going to plan on taking option A unless you say otherwise, right? So,
Hmm.
but if you're able to kind of come up with those numbers or those expressions, that's a very very good sign, right?
Okay. Yeah.
Now,
I think, yeah, I am kind of in the habit of just assuming that we should always prioritize on runtime, but
yes,
yeah,
I mean, and
definitely
that
I
is
should.
almost always true, but sometimes it's not, and it's not about showing off that you know the. It's not about that. It's about the format. It's about like telling the interviewer, hey, I'm very organized. I've got these ideas. Here's what I'm gonna do, right? Like here's what I
Hmm.
plan on doing, which is a time optimal one, and then if they want to steer you otherwise, they can, right? So it's about bringing the interviewer to your world to let them know what you're thinking of, and letting them interrupt you and letting them correct your course if they so choose, right? That's not a negative thing. Think of it that way. Could that be construed as a negative attribute? That can't, right? So that's totally fine. Um,
Okay.
Now I did want to talk about a bit about space, because your space complexity here wasn't exactly right. The space complexity for your original solution is correct, so it is O of m, which is the size of the heap for that. However, the follow up question wasn't quite answered correctly. For example, when I said, "Hey, if you were to well, I mean, you said this. Hey, if n is proportional in, we would always just sort the solution, or sort the array." Um, that wasn't exactly correct. I think like your reasoning there, because you would say that because your implied topic was that the sorting doesn't have a spaced overhead, which is not really true. Sorting still does have a space overhead. In this case, if you're using default Python sort, which is tim sort, it would be O of n as well. And so
Oh, okay.
and that's true
Aren't
for
there sorting algorithms that would just sort the array in place though?
there are, but they're usually not as efficient. You can do, for example, I mean, there are algorithms, but you have to clarify that, and that's not always the case, because in this case you're using a language you're not very familiar with, and the interviewer's not going to have confidence in that, right?
Okay.
Um, Let me just quickly check my notes again. So I mean, it's just one of those things where you have to just mention it, right? Because if you're using default sort, which is what you would have done, that would have been O of n as well for space. Now, for example, because points are not object, well, there depends how you define them. In other words, like you can use quicksort instead of tim sort. Quicksort, I think, has login space, so you could use that as a justification, for example.
Hmm.
But you didn't say that, so
Okay.
so
Yeah.
that's not gonna exactly work. I don't believe. Yeah.
Okay.
Yeah, and then one more thing about the end there about the space complexity with k dimensions is that the space actually wouldn't scale with k, right? The space wouldn't scale with k because the distance is still a single number. So you wouldn't be storing k distances; it'd just be still one distance. So the space complexity wouldn't change. So that's a detail you missed at the end there as well.
But like for our return array though, we're essentially creating a copy of the m smallest elements, like the actual points themselves, right? Wouldn't this take up mk space?
Yeah, that would take up NK space, but that wouldn't be due to the Euclidean distance, and that's part of the return. So that would be something which you would like. Yes, the algorithm will still take mk space. That is correct because that is the size of the return. That's the bound. But your justification for the justification you used was pertaining to the distance, which I perceived as this, which is not the case. This is the part you were pointing towards as you were saying the space. So
But with our current approach, where we
yes.
store both the point and the distance, wouldn't it
Oh, I
would be
see.
mk, right? If we optimize that away, where we only store like the distances, and we could just grab the points in the end, like that wouldn't be it wouldn't
Yes. No.
scale
Actually. No.
mk, right?
Actually. No. Actually. I got confused here. You're right. This is still like even this is still MK. The part I got
Mhm.
confused by was I got ahead of myself there. I know we're a bit over time there, but if you have a bit of time, I want to chat with you a little bit about what I was going to get to as well.
Yeah, for sure. I have time.
Cool. Which is the tie break, right? What I was going to get at there was actually the fact that um, the solution most people use to tie break is not to push the points.
Mhm.
Sorry, which is this point, which is not to push the point onto the heap, right? And the reason don't push the point on the heap is because you actually don't care about the point. What you actually can push instead is the index,
Ah, okay.
and that would
I
get
see.
around, this being mk space. That would just be m space then, the distances I mean.
Right.
And the way
Okay.
you would do the tie breaking is that instead of just comparing the distance, which is this field over here, you would put in a second variable in the tuple for the index,
Hmm.
and that would be used as a tie break comparator.
Okay. Yeah. Gotcha.
So
But like
that's the
the
part I was
actual
thinking about. Yeah. Sorry. Go ahead.
right. Because I still think the tiebreak is not necessarily this simple. It's kind of just whatever element gets floated to the top of the heap when you happen to call, I think, heap pop. Um, I think we might have to do some kind of override of the heap queues comparison function in this
You
case, though.
uh,
Correct me if I'm wrong.
I mean, so yes and no. So that would open another can of worms because that would really depend actually. So this is a good point. That would actually depend on precisely how many ties there would be, but we don't actually need to override the comparison function,
Hmm.
and that's simply because it's a monotonic truth that if we had, for example, like let's say we had m equals 3, like your example, and we had two ties, we only care about the best tie, right? Like of all the tied points, we only care about the best one or the best two of them. Because if we were to find a point that's closer than the ties, then we only need to care about the best one tie. So we wouldn't actually need anything as complex as overriding the comparison function for the purpose of solving
Okay,
ties.
wait. I'm not sure I follow. So by best tie, like if they're tied three ways,
Yes,
for example, like they would all have the exact same distance.
they would. Yeah, but they would have different
so
indexes,
what
right?
do you mean? Oh, right. Yeah, yeah. Okay. Right, because we only care about the smallest index. Okay,
Yep,
that
we
makes
would put the
sense.
smallest index first. Well, it
Okay.
doesn't matter. That's what I said, but it doesn't actually matter what order they're in as well.
Hmm. So like how would we because like inside the heap, like let's say we have a tie, right? So let's say we have one point already with like some distance, and then we have another point further down the array
Yep,
with a different distance. And then the first point is already in the heap.
yep.
So how do we actually find that points index? I guess we could keep like a hash map
I mean,
of like
you wouldn't
the
need that points index. You would encode the index into this. So, for example, let me just do this for you. So, um, distance equals this. What am I missing? I'm missing that. So you would be doing dist I as the encoded comparator.
Oh, okay, I see. Because we're comparing the entire tuple, which includes the distance and the index. So the okay.
Yep.
Okay, wait, that's really smart. I didn't think of that. Okay, that makes sense.
Yeah, there's a reason that's not part of the default Leetcode question.
Mhm.
Okay,
Okay,
so
so like the comparison function in Python, it will just take the first element, but then if you like bundle several things together in a tuple, it will just take the whole tuple.
what's still the comparison logic for tuple is as such: compare the first element of the tuples, and if there's a tie, compare the second, and if there's a tie, compare the third, etc.
Okay. Okay,
So
I'm actually kind of not too clear on how the tuple comparison works, so I definitely need to kind of read up on this a bit more, but this is very helpful.
yep,
Thank you.
you are welcome. Um, Otherwise, there's some notes I'll send you later on. But yeah, this problem gets quite advanced. I'd say for today's kind of level, we kind of only touched base on like the medium area. We didn't get to the kind of the harder follow ups. But
Hmm.
just be aware that like yeah, I think a lot of the hold up here was your unfamiliarity with Python. I think if you were faster
Okay.
with Python, like because it seems like you knew the algorithm for a long time, you just couldn't write it, right? That's actually rarely the bottleneck with Python. So I would suggest, yes, using Python is good, but you should really try to get familiar with it so that becomes less of a bottleneck.
Okay,
Because a lot of
sounds
these
good.
problems, especially, and you can, by the way, you can sort of metagame this a bit, right? If you're going to a company interview where you know they're going to be asking more difficult questions, and they're giving you
Hmm.
this medium question up front, because the question you mentioned, the top K numbers, that's also medium, right? Like
Hmm.
if they're giving you a medium that sounds like a medium, you should know that that's not the real question, right? This is either a warm
Right.
up or there's a follow up that makes it not a medium. And so you should be really trying to get through the question as is as soon as possible, right?
Right,
So
because I
just
have
be
to
aware
make
of that.
space for the actual follow-up.
Yes, and you have it's not just make space. You have to make enough space because if you finish it, let's say it takes you 35 minutes to code it up, right, to up to here, and
Hmm.
then the follow up is a hard question that makes this hard. For example, let's say what if we make this an online algorithm? That's a typical follow up for this, right? The interviewer will not have confidence that you can do that in 10 minutes, and so they just won't ask it, right? Because you'll
Hmm.
have a bad experience. They know you won't pass, and so they'll just fill it up with some like random ass shit instead. So you have to just be cognizant of that. Like you have to be fast. If you know they're gonna be asking harder questions and it's an easy one that comes up first, you have to be fast. That's the only thing you can do for yourself. So just be aware of that.
Okay, sounds good.
Cool. Any
You
questions?
mentioned you mentioned the hard follow-up is like turning the algorithm into an online algorithm, so could you explain a bit what that means?
Yeah. So there's a couple follow ups. Generally speaking, the online algorithm goes as follows: define a class that does this, and also a second function. To define a class which does this, and also include two functions. First function, add point. Second function, query k closest.
Um, okay,
So that
so
so it's the
is it
same.
essentially ask? Sorry, go ahead.
Yeah, so it's the same. It's a very similar premise, except now you can modify the points live. You can add and remove points, and then you can also query the m closest points, but m changes with every query. M can change,
Okay, I see.
and then that's like a pretty standard like for in new grad kind of stuff like a pretty standard kind of level, and then a real hard follow up there, which is unreasonable to ask, but is actual hard follow up, is k closest, but to a point in the already like in the list already. So not to the origin, but to another point.
So we're not comparing against the origin, we're comparing against some other point.
Yes,
Okay, so I can't immediately see why this would be a super hard follow-up.
it's a
Is
super
it
hard follow up because it requires a complete rewrite of the data structure, and it requires you to know some pretty advanced tree and graph and potentially geometry if you want to get optimal.
okay, gotcha. Yeah, I guess we don't have to time to open that can of worms.
We don't have the time. We don't have the time, but you
Yeah.
can go search yourself, like a quad
Hmm.
tree or a KD tree or a KNN tree. So you can go search those up yourself. But yeah,
Okay.
so there are advanced questions that are follow ups for this kind of thing. But again, like a reasonable follow up would be turn this online or M can change.
Okay, sounds good.
Okay, that's all the time we have for today. Thank you for participating, and hopefully we'll see you again soon. Take care.
Thank you so much. Have a good one.
You too.
Bye.
All right. Obviously, we went a bit over time there. Yeah, but sometimes it's a good conversation. You just have to stay around a little bit. Okay, but we are doing resume reviews now. We are doing resume reviews, which means I need my form. It is over here. Live stream. Submit resume. Is that correct? I think so. All right. Oh, do I have a custom keyboard? I'm glad you asked. Yeah, I do. Why can't I see your comment? Why is it going away? Okay, when I pin my message, there's a pop-up in the chat that covers your message, so I can't see what it is now. But yes, I do have a custom keyboard. I was really into keyboards during COVID, and I, yeah, got myself a nice keyboard. The switches I have are really clicky. They're the KLH box jades, which were really popular when I was around. But maybe I should get a new keyboard. I don't know. What do you guys think? Okay, what's the date? The date is 4/26, and we have one already. Okay. All right, let's take a look. Okay. All right. So this person's comment is realistically looking. Let me expand. Realistically looking to get into either full stack, back end, looking for internships, ATM, looking to get into, and I'm also looking to enter second degree for CS, or push back current degree. I can finish December 2025. Like I wrote. Okay. I'm very confused. So what's your degree? Operation manager, minor in computer science. Oh, okay. I see. Okay, interesting. Let's have a look. So, looking for internships, and also looking to get into a second CS degree program. Okay, that makes sense. Yeah, right now, market's pretty tough if you don't have the right credentials, even so. They'll deploy backend for blah 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 blah. Okay. One of the app's core engagement tools. Okay, cool. Some Figma. Okay, migrating from Java to SQL. Okay, okay, I like that. Always like that. That makes sense. This is a while ago. This is a year ago. I mean, this is about this is kind of what I would expect. Like kind of 3-4 months kind of thing. Kind of makes sense. Develop deploy backend. So yeah, I mean the thing that this is like pretty surface level, right? Like this stack is just pretty surface level. That's okay. But if you did anything advanced like configuration or any like comparisons, performance comparisons or considerations on that front, that could be good to put in. Otherwise, I think when people see these three words, they're like, okay, I know where you are. Like not as in like a workplace, but like level. Okay. Okay, course alert platform, students real-time Python, open. Okay. React, Spring Boot, JBT, rate limiting, Postgres, WebScript and Python, delivery, SCS. Okay. Makes sense. That's pretty good. I would say for this kind of thing, I'll put a date there by the way. But for this kind of thing, I would consider numbers like, for example, what's the latency? How soon after the seat opens do people get emails, right? Like that I would think is like a defining factor of this project, right? So I mean, and the thing is, it doesn't need to be impressive, right? This isn't impressive. That's not the goal. The goal is to make it sound like it worked, and it seems like it worked, so that's good. But like how well did it work? That's something which people are the people are going to be questioning next. Is does it work? Okay, it does work, and then was it good? So just be aware that that's like often close follow-up. Okay, let's take a look. Project Kotlin Firebase, Android app, eco-friendly fashion platform. Place runner-up in this thing, help you sustainable wardrobe choices. Interactive fashion map with custom markers, dynamic filters, support brand discovery, promote sustainable fashion trends. Okay, so this sounds like maybe like a hackathon kind of thing. This sounds pretty cool. If you could have like a GitHub link, that would be really good for people to click it and see like in screen recording, screen cap, stuff like that. That could be really good. It's a bit vague still. I would maybe say, right? Like Um, like I think that's fine. I think it's fine actually. Yeah, Firebase, Firestore, tracking balances, personalized quiz history. Okay, this product feels a bit smaller. Feels a bit smaller, so I think the next thing to do is to kind of get that pumped up. But let's see what curriculars you have here. So, friend developer, work for free, no contract, not officially employed. Okay, that's cool. Improve page load time, processing API requests, content loader, server side pagination. Okay, that's good. Integrated Stripe, that's good. University Club, React Native mobile app, TypeScript, collaborating, Figma, refined UX. Okay. Okay, I hope the name of this thing makes this app obvious what it is, because I don't know what it is right now. But the Discord bot, Node, Notion API to automate role synchronization, dynamic permissions, 100 active members. Yeah, that makes sense. That's cool. Vice President, University Club, led weekly meetings. Okay, that's fine. Okay. So I think, yeah, the main thing here is that there's just a pretty big gap in employment, and because you're not in a major computer science, it actually would, I'd say, be helpful in this case to put in relevant courses, because that's a question that people will have is like, is this guy taking courses or not? Like, what's going on here? So this is one of the very, very few times, I think maybe the first time ever, I've advocated that you should put in relevant courses, because it's not clear what you've done here in terms of school. And I'd say, yeah, given this, if you're having trouble, yeah, it's not a bad idea to consider it. It's not a bad idea to consider a second degree, in CS specifically. Okay, let's take a look here. What am I doing? I don't want files. I want. Okay, this person does not have a Discord username. That's fine. That means they're probably not from Discord. Where are they from? Oh, I don't know. Doesn't matter. Doesn't matter as long as they don't take my stream down. Okay, let's take a look. This person's comment is software developer role. Great. I can't tell if people write nothing because they're lazy or because they just don't know what to write. Anyways, that's not relevant. That could be relevant. What are you going for? You're going for software. Okay, so this is what I'm saying, right? If you're going for full stack software, get rid of that immediately, and I would say get rid of that as well, because then you can save the space. If you're going for systems roles or backend roles, then this would be relevant. But what's more relevant than having the course listed here is having a project. That's not this. Okay, so again, that's why it says depends, right? It depends on what role you're going for, because you just said software developer role, which has no information. Okay, let's have a look at this. So software developer, React.js, interactive kiosk, maintaining agile sprints. Don't say that. Don't say that. Don't say the stuff about this is not a skill. It's not a skill to be agile, okay? So don't say that. Okay, that's cool. That's good. Engineer 10 scalable digital signature platforms with automated continuous deployment pipelines, enhancing deployment speed and reducing errors across deployment. By how much? This is a big claim, and so you need some numbers. Okay. Collaborate directly with enterprise clients to gather requirements, deliver customer solutions, blah, blah, blah. Okay. Yeah, this is a bit vague, but I can see this is probably a contracting kind of thing, so that's fine. Because I don't see anything that's tying these three together. Develop data pipeline using Azure Connect Surface Tracker, SQLite. What is this? Innovate. Okay, what does this mean? Enabling marketing teams to create targeted strategies. Improving data accuracy by 50%. Okay. Okay, sure. Increase customer engagement by 20% by designing and implementing a Python script to process your data. Delivering actionable insights that optimize retail marketing strategies. Increased customer engagement by 20%. Okay, so this I feel is like a stretch, right? You're saying so you made a Python script to process user data to come up with insights, right? That's sort of what you've done here, and then I think what you're saying here is that the insights you gave then led the marketing people to increase engagement. That's like their skill, not your skill. So what you've done here is just the first part of the sentence. right? I think we've leaned on that a bit because otherwise people will see this and say, oh, you're over crediting yourself with other people's work. Bones are graph simulation, blah 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 blah. Okay, this is fine. Software engineering intern, SAS, MERN, 98 test coverage. So, again, this is what I'm saying is, what kind of test? When you're saying percent test coverage, it's obvious it's unit tests. I personally would not put unit test points on the resume, and that is because unit tests are not a skill. It does not require skill to write unit tests. So unless you can say that the unit tests were added for a particular reason, that's not like just. Of course, you write unit tests to ensure reliability and to reduce this kind of stuff. But can you quantify it? Like, did you previously have not enough unit tests and the incident rate was very high, and then when you increase the test coverage, that went down. That is like a reasonable reason to put unit test on the resume. Otherwise, I think if you're just wishy-washy, say, oh, then this will probably help later on, that's not a good point in my opinion. Deployed SaaS, okay. Reducing, so again, right? Quantify that. Implemented secure authentication, JWP passport, CO, okay, sure. Firmware, logic control, STM32. So cross, okay. Okay, that's cool. Okay, yeah. Heart disease predictor. Python, that's lowercase s, that's lowercase p. Validated, okay, blah, okay. Unprinted search, okay. Okay. I mean, this feels very, very, very basic. This is like a school project kind of thing. And from what I can tell, you're not going for. I mean, this is obviously not an ML resume. So I'm not really sure what this project is doing here, to be honest with you. There's no like full stack front end back end considerations here at all. It does it purely ML. So unless you're going to ML or data science, this feels like not a good use of space. Splash rent, SaaS, MVP, okay. Yeah, okay, sure. This makes sense. That's cool. That's fine. So say high level wise, this product doesn't really make sense, and some of these points you got to quantify or get rid of them. Otherwise, they're kind of out of place, to be honest. Okay. All right, that's all the ones from the submission form. So I'm gonna go to Discord and fetch them from there. I think I have time for like maybe 2 or 3 more, so I'm gonna just do that real quick. Now, where the fuck is the resume channel? Resume feedback. Resume reviews. Here we go. All right. Let's have a look. Which is also an invitation for you guys to submit them on the forum. If I don't see them in like 5 minutes, I'm gonna call them. I'm gonna call the stream there. Okay, so this person's comment is, I feel my resume is lacking. Trying to improve it. Any advice appreciated? Side question. My year-long experience is volunteer, part-time with supervision from my professor. Other experience is paid contracting project. Got matched with companies. When companies ask how many co-ops terms I've completed, do I state 0? Okay. All right. So, this person didn't say what their goal was though. Okay, well then you know the drill. If they don't say the goal, I'm assuming it's full stack software. All right, so a lot of relevant courses here. I don't think they're all relevant. For example, this is completely worthless for any employment basically. These are not useful either. This is not useful. So I would say yeah, you can get rid of so these 3 are gone, and I'd say get rid of probably this one. This is a show don't tell, right? Show don't tell. Okay, blah, 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 that's fine. Okay, so let's take a look. So this is the one you're talking about, the professor, presumably. Okay, Postgres. Oh, that's a big number. That's a big number. Nice. Refactor backend adjustment WebSockets. Okay. System efficiency, okay. Our spec. Unit test point. Maybe we'll let it slide. We'll see what else you have. I mean, this feels like overall a pretty decent. Piece of experience though. So I don't think there's anything. So what was your concern? Your concern was. Oh, that's not a concern. Just say you had a year-long experience with a professor, and your other is paid contracting. How many co-op terms I've completed? Do I state 0? I mean, these aren't co-op, so yeah, you'd state 0, but you wouldn't. I mean, usually people don't ask you how many co-op terms they usually ask like, what experience do you have? And to answer that, you can just say, oh, I've got about I don't know how long has this been. I've got like a year and a half paid experience, paid internships, that kind of thing. So you wouldn't be measuring that in terms because it's not co-op, but you can still talk about experience. Yeah, nothing wrong with that. Okay, develop DI consulting tool using Google Apps Script, TypeScript, on automated analysis, blah 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 blah. Okay, reducing manual. Okay, that's good. Yeah, I like that. Automation's good. Linked TypeScript output to Google Sheets, creating dynamic graphical representations of data, enabling stakeholders to visualize trends and insights. This is. I'm not really sure where this is. Is this about the first one, or you said these are separate companies? So you did one, you're doing the second now. Okay, so this feels a bit wishy-washy. Like, for example, what's wrong with the built-in graphing tools? I don't understand what the thing is here, right? If you're going to the next level, for example, you want some real data visualization, people will be going like, Tableau or like, Power BI or something. So it's a bit weird to still keep it in Google Sheets. I would probably expand upon this point a bit more and just explain why this is good. Automated end-to-end workflow, blah, 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 blah. Okay, this is good. Okay, so let's take a look. Develop productivity tool, Gemini, OAuth 0, OAuth 2. RESTful APIs, I will put the tech stack here. Oh, do you have the tech stack here? You have Node, I guess. I guess is this Express? Is this raw Node sockets? Like, what's going on here? Parse syllabus, calendar settings, collaborate team. Okay, that's cool. Design implemented multilingual messaging platform. Okay. Default translation service additions. Okay. Okay. Lead collaboration efforts to get version control. I would not put that as a point personally. That's good. Oh, that's good. I like that. MVC. Talk about some MVC. What is this? What's the app here? Chat. This is presumably like an Android app. Okay. AI video generator. Some stuff there. Collaboratively designed, implemented. Generated content. 6,000 moves. Okay. Red API. Okay. This is pretty cool. Yeah, I mean, I feel like the resume isn't weak. I mean, your concern was that it's weak. I don't think it's lacking or too weak. I think the points are actually pretty decent, and I think what you should be focusing now is not. You should be focusing now is actually about making sure that because you've got like 2 ongoing pieces of experience here. I mean, this one's almost over, right? But you've got you've got more experience to be had over here. I'd say you should be focusing your effort on making sure you get the most out of this experience over here. Like you should be focusing on how you can do more to impact your projects with this professor. That should be the goal, and that would naturally cause the resume to be better in the future as well. So don't focus on rephrasing the resume wording. That's like small fish. Big fish is actually doing better work at your current job. Okay, we got one here from the submission. This is the last one I'll do for today. All right, so let's take a look. Looks good. The comment here: first year student going to second year looking for software. Want to maximize what I currently have on the resume. Also got experience in a few front end roles at a few clubs. Let me know what I should put on there. Okay. Okay, so we got some stuff here. Okay, ML and designer. Okay, 49 point data model. Okay, Pandas on Pi. Okay, makes sense. Good summary point. Blah blah. Stable based on temperature and oh, okay, cool. Is this actually tested? This is actually very cool. I think this would be this should be in the first or second point, because this actually has the outcome. That's good. Comprehensive testing. Okay. Validation framework, cross validation methodology ensure model robustness across the version. Okay, this is fine. This is a good place to put it. Okay. DevOps. Enhanced what's a guy. So again, if you're using the adjective enhanced, you gotta be comparative, right? So you moved it to DigitalOcean from what? If it's from AWS to DigitalOcean, I don't think that enhances web reliability, for example. So if you're gonna use a comparative adjective, you gotta put the comparison in the point. DS Management, Cloud for JSON. Okay, that's fine. Okay, so online web app. Okay, React, Next.js, Postgres, blah blah, MFA. No, okay. No, I think this is good. This makes sense. I think I've seen this resume before actually. This rings a bell. This rings a bell. I like this point. I think this point is, see, this point makes sense, right? Like this thing you're saying, okay, we've done something to have really high security, to have really good coverage. because we've done a certain thing, right? So this is a thing which is like, oh, this point isn't just about testing. This is like, oh, this is actual security because you've done something about the product. So this point makes sense to me. So this is, I would say, this is a good point. What is this AI stuff? Blah 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 blah. Okay, this is like whatever. This is like an AI project. I mean, like AI projects are fine, they're fine, but just know that AI projects actually have no value in terms of employment because you won't be hired to make AI projects. Like that's just not how things work in the real world. So you should use this to like say that you're very fun, you can do some fun stuff, but just recognize that none of these skills are actually relevant in terms of like AI, right? So React is good, Next is good, but you don't need to say that here because you have a better example over here, right? So just be aware like that. Like no, that's how recruiters are looking at this. Num num, what is this? Restaurant application. Okay, that's fine. Split that out. That's fine. So I think actually, in terms of maximize what you have on the resume, I think that's fine. I think you've kind of been there already. I wouldn't say that's a concern. I'd say the main thing now is thinking about what projects you're putting on the resume to convey what you want, right? So there's a lot of duplication here. All three of these guys have React and Next. All three are React. Is this TypeScript as well? I don't know. This one's TypeScript. All three are React and Next. I would say, how about you diversify a bit and make another one that's focused on the back end, right? Because this one you're using Express. This is Express. What is this? This is Flask, right? So these are all very simple backends. You should consider a project that has a more complex backend that has more of a performance consideration. That way you can diversify the skill set in the projects here and then appear a bit stronger. Because by the third time I see React and Next, I get it. React and Next. I get it. Okay, like you don't need to spend so much room on that kind of thing. So just be aware of that. That's the kind of next thing that people will be looking at for improving the resume. So little tip for you there. Okay, that is all the resumes I see on the submission, and so I will be ending the stream here. Thanks for tuning in, everybody.